Hello students, now we'll see age triggered flip-flops. Normally, digital systems are either synchronous or asynchronous or asynchronous. Now, in asynchronous digital systems, the output of the logic circuit can change at any instant of time depending upon the input. Okay. While in case of synchronous system, the output will change at exact time at which the input will change along with the clock. So commonly used, or I can say that a signal is given which is called as a clock. So the flip-flop using the clock signals are called as clocked flip-flops. Okay. So the control signals are only effective only when the clock signal is available. Unless and until the clock signal is available, the control signals will not have any effect on the output. Basically, the clocked flip-flops are first positive age triggered, or negative age triggered. In case of a positive age triggered, the state transition takes place only at the positive going edge of the clock. While in case of negative age trigger, the output will change, or the change in the output will take place during negative going of the clock signal. That's why this is called as a positive age triggered and this is called as a negative age triggered. Normally, positive age triggering is indicated by the triangle at the clock input, while the negative age trigger is indicated by the triangle as well as the bubble at the clock terminal. So like this. Okay, so the indication is this is for positive age triggering and this is for negative age triggering. Okay, so these are symbols normally used for showing the flip-flops which are positive triggered and negative triggered. Okay, so when we are considering this flip-flops, before considering the flip-flops, we should know this basic concept of the triggered flip-flops. Now, first of all, we will go for age triggered SR flip-flop. Okay. So we will see first age triggered SR flip-flop. The logic symbol of the age triggered SR flip-flop is like this. This is S, this is R, Q and Q bar are the output, and triggering will be denoted like this at the clock pulse, where this is the clock pulse provided in this fashion. Okay, so here this is a positive age triggered flip-flop, SR flip-flop. Now S and R are the control signals which are synchronous control signals along with the clock. Without a clock pulse, S and R inputs cannot affect the output of the flip-flop. Now, when S is high and R is low, the Q output will goes high at the positive age triggering of the clock. While when S is equal to 0 or low and R is equal to 1, it means high, Q is becoming as a 0 at the positive edge of the clock pulse. When both S and R are 0, or I can say low, the output does not change from the prior state. So Q is equal to Q0, whatever may be the prior state. While when both S is equal to 1, R is equal to 1, simultaneously invalid condition exists. Okay, so when the 1 and 1 is there, S and S is 1, R is equal to 1, the invalid condition is there. So the truth table of this particular SR positive age triggered flip-flop is like this. Inputs, yes, R, clock, then output and comments. Okay, and this is like this. Okay, so when S and R are 0 0 and clock is positive going, okay, in that case S and R both are 0 0 and clock is positive going. This is third condition. As we have seen, the output is the previous state only, which we can call it as a Q0, and there is no change in the previous state from the previous state. When S is equal to 0, R is equal to 1, and when positive edge is going on, the output is S is equal to 0, R is equal to 1, Q is equal to 0, which is a reset condition. When S is equal to 1, R is equal to 0, Q and positive edge triggering is going on, output is 1, which is called to be as a set. And when both are 1 1 and positive edge triggering is active, then it's an invalid position. Okay, so this is the truth table of the age triggered SR flip flop. Thank you.